Langchain Azure Dynamic Sessions Tools. Description: The Langchain Azure Dynamic Sessions tools are a collection of tools designed to integrate Langchain with Azure OpenAI Service and leverage Azure Cognitive Search for dynamic session management. These tools enable building conversational applications that can access and process information from Azure Cognitive Search and leverage the capabilities of Azure OpenAI models. Inputs: Azure OpenAI Service API key, a required input for authentication and access to Azure OpenAI models. Azure Cognitive Search endpoint, a required input for accessing and querying information stored in Azure Cognitive Search. Azure Cognitive Search API key, a required input for authentication and accessing Azure Cognitive Search. Prompt: the user's input text or query, which is sent to the Azure OpenAI model for processing. Outputs: chat response, the response generated by the Azure OpenAI model based on the user's input and pay. Information retrieved from Azure Cognitive Search. Relevant documents, a list of documents retrieved from Azure Cognitive Search that are relevant to the user's query. Steps: initialize Azure OpenAI and Cognitive Search clients, establish connections to Azure OpenAI Service and Azure Cognitive Search using the provided API keys and endpoints. Process user input, extract keywords or entities from the user's input to generate a search query. For Azure Cognitive Search, retrieve relevant documents, use the search query to retrieve relevant documents from Azure Cognitive Search. Enhance prompt with document information, inject information from the retrieved documents into a prompt sent to the Azure OpenAI model. Generate response using Azure OpenAI, send the enriched prompt to the Azure OpenAI model for response generation. Metrics: response time, measure the time taken to generate a response, including document retrieval and model inference. Document relevance, assess the relevance of the retrieved documents to the user's query. Response quality, evaluate the quality and coherence of the response generated by the Azure OpenAI model. Visualization plots. Document retrieval timeline, visualize the time taken to retrieve relevant documents from Azure Cognitive Search. Model inference time, visualize the time taken by the Azure OpenAI model to generate a response. Response sentiment analysis, visualize the sentiment positive, negative, neutral of the generated response. Fine-tune parameters. Azure OpenAI model, select the appropriate Azure OpenAI model, e.g. Text DaVinci 003. GPT-3.5 Turbo based on the application's requirements. Temperature control, the creativity and randomness of the Azure OpenAI model's response. Top: adjust the probability distribution of the model's output to balance creativity and coherence. Uncertainty methods. Confidence score, Azure OpenAI models can provide a confidence score for their responses, indicating the level of certainty in the output. Document relevance score, Azure Cognitive Search can provide relevance scores for retrieved documents, indicating the degree of match with the search query. Challenges and fixes. Challenge 1: handling ambiguous or complex queries. Sample use case that resulted in challenge 1: user enters a query that can be interpreted in multiple ways. Fixes to challenge 1: implement query disambiguation techniques to identify the user's intent and generate appropriate search queries. Challenge 2: ensuring document relevance and avoiding information overload. Sample use case that resulted in challenge 2: Azure Cognitive Search retrieves a large number of documents, including irrelevant ones. Fixes to challenge 2: implement document ranking and filtering mechanisms to prioritize relevant documents and reduce the number of retrieved documents. Challenge 3: managing session context and continuity. Sample use case that resulted in challenge 3. User engages in a multi-turn conversation, but the model fails to remember previous interactions. Fixes to challenge 3. Implement techniques like session history management and context tracking to maintain the conversation flow and provide consistent responses. Challenge 4. Handling sensitive data and ensuring privacy. Sample use case that resulted in challenge 4. Users' input or retrieved documents contain sensitive information. Fixes to challenge 4. Implement data anonymization and access control mechanisms to protect sensitive data and ensure compliance with privacy regulations. Langchain Azure Dynamic Sessions Tools. Sessions Remote File Metadata. Description: the Remote File Metadata tool provides information about a file stored in Azure Blob storage. It's used within Langchain's Azure Dynamic Session to access and manage files associated with a particular session. Inputs: file path, the path to the file in Azure Blob storage. This path is relative to the container where the file is stored. Outputs: metadata, a dictionary containing metadata about the file, including its name, size, content type, last modified time, and other relevant details. Steps: the tool uses the Azure Blob Storage SDK to access the specified file. It retrieves the metadata associated with the file. The metadata is then returned to the user as a dictionary. Metrics: latency, the time taken to fetch the metadata. Number of API calls, the number of calls made to the Azure Blob Storage API. Visualization plots: file size distribution, a histogram showing the distribution of file sizes in the Azure Blob storage container. File type distribution, a pie chart showing the distribution of file types in the container. Fine-tune parameters: none. This tool does not have any fine-tune parameters. Uncertainty methods: none. This tool does not have any uncertainty methods. Challenges and fixes: challenge 1, accessing a file that doesn't exist. Sample use case that resulted in challenge 1: a user attempts to access a file using a path that doesn't correspond to an existing file in the Azure Blob storage container. Fixes to challenge 1: the tool should handle this scenario by returning an appropriate error message or a none value for the metadata. Challenge 2: accessing a file with insufficient permissions. Sample use case that resulted in challenge 2: a user attempts to access a file that they don't have the necessary permissions to read. Fixes to challenge 2: the tool should handle this scenario by returning an appropriate error message or a none value for the metadata. Langchain Azure Dynamic Sessions Tools. Sessions Python REPL tool. Description: explain in detail. This tool provides a Python REPL read eval print loop within a Langchain session, allowing users to execute Python code directly. It acts as a bridge between the language model's capabilities and custom Python code execution, making it possible to perform complex operations and retrieve specific data. Inputs: Input 1, explain in detail the Python code to be executed. It can include variable declarations, function calls, and any valid Python statements. Input 2, explain in detail the context of the current session, potentially including variables, functions, and previous code executions. Outputs: Output 1, explain in detail the result of the executed Python code. This can be any type of data supported by Python, including strings, numbers, lists, dictionaries, or custom objects. Output 2, explain in detail any error messages or exceptions raised during code execution. Steps: Step 1, explain in detail. The tool receives the user's input Python code and the session context. Step 2, explain in detail. The code is parsed and executed within the Python interpreter within a session environment. Step 3. Explain in detail the result of the execution or any error messages is returned to the user. Metrics. Metric 1. Explain in detail code execution time, measured in seconds. Metric 2. Explain in detail the number of lines of code executed. Visualization plots. Visualization plot 1. Explain in detail. The tool doesn't inherently create visualizations. However, you could potentially use the Python REPL to generate data that could then be used to create plots. Using visualization libraries like Matplotlib or Seaborn. Visualization plot 2. Explain in detail na. Fine-tune parameters. Parameter 1. Explain in detail na. Parameter 2. Explain in detail na. Uncertainty methods. Uncertainty method 1. Explain in detail na. Uncertainty method 2. Explain in detail na. Challenges and fixes. Challenge 1. Explain in detail unintended side effects. Executing code within the Python REPL might unintentionally modify variables or functions in the sessions environment. Sample use case that resulted in challenge 1. A user inadvertently assigns a new value to a variable that was previously used in another part of the conversation. Fixes to challenge 1. Careful code design. Developers should pay close attention to the scope of variables and functions when writing Python code for the REPL. Sandbox environment. Consider using a sandbox environment or a separate Python interpreter for each user session to isolate their code execution. Challenge 2. Explain in detail. Errors during code execution can disrupt the conversational flow. Sample use case that resulted in challenge 2. The user enters a code snippet with a syntax error, causing an exception. Fixes to challenge 2. Error handling. Implement mechanisms to catch exceptions and provide informative error messages to the user. Graceful degradation. If an error occurs, the tool could attempt to recover by providing alternative responses or suggesting corrections.